Algebra 2, Part 2. This is Section 872, which is applications of minimum and maximum. So we're going to be doing word problems that involve finding the minimum and maximum values of a quadratic function. So by the end of this, you should be able to solve those word problems. And when we find these minimum and maximum values, what we're really doing is finding the coordinates of the vertex of the quadratic function or the parabola, however you want to refer to it. So a few strategies or some things to go over when we're doing these. These application problems, they involve quadratic functions, which you know when you graph them are parabolas, and so when we're working with these problems, what we're really finding are the max and min values or the vertices. And so there are two parts to every vertex of a parabola, the x-coordinate and the y-coordinate. So probably the most difficult part of doing all of these word problems is knowing if they're asking for the y-coordinate or the x-coordinate. So you know that in order to find the y-coordinate, you have to find the x-coordinate first, right? So to find our x-coordinate, we do negative b over 2a, and then we can plug that in, and then we can find the y-coordinate. Most of the problems will ask you to find the max or min value, which is the same thing as the y-coordinate. Some of the problems, the wording will be different, and they'll ask you to find when or where the max or min value occurs, or what quantity gives the max or min value. So that's not the same thing as the y-coordinate. And for those problems, what you're finding is the x-coordinate. Okay, so the key thing is understanding which coordinate you're finding, whether it's x or y, and then going about and taking the proper steps to do that. So a few quick things about minimum and maximum values. Remember, parabolas that open up look like this, and they have a positive a value, and their vertex is going to be a min. And then parabolas that open down, they have a negative a value, and their vertex is going to be a max. Okay, and so to find these, the first thing that you always want to find a min or a max value is you have to find the x-coordinate of your vertex. And remember, the x-coordinate of your vertex, it's that formula, x is negative b over 2a. And then what you can do is you take that value and you plug it in, you evaluate the function at that value, and so after you plug that in, then that gives you the y-coordinate of your vertex. Okay, so all of this is the same thing that we were doing when we were finding the vertices of parabolas a few classes ago, except now we're just applying all of this to word problems. So we'll go ahead and we'll do some word problems, and then you'll have some in your homework to try on your own. So for number 1, we have the height and feet of a rock thrown straight up is given by the function s of t is negative 16t squared plus 96t, where t is the time in seconds. Find the maximum height above the ground that the rock will attain. All right, so I just want to draw you a quick picture of what's happening here. So if this is the ground, right, and you're throwing a rock up from the ground, the rock follows a parabolic path. And so it's this upside down parabola. And so we have this function that the word problem gives us, negative 16t squared plus 96t. And this function is a good model of the path that the rock takes, the parabolic path that the rock takes, because if you notice, our a term is negative, and you know with a parabola that has a negative a term, it should open down, right? And that's what you can picture right here. That's what I've drawn, is this parabolic path for a rock that's opening down. Okay, so what they want us to find is the maximum height. Okay, so we know the vertex on this is going to be a max because it opens down. And so if they're asking us to find the maximum height, well, that's kind of like asking us to find the max value. And so what they're really asking us to find is the y-coordinate of the vertex, right? And so then the first thing that we want to do is we want to find the x of the vertex, and we'll use negative b over 2a. And so for the given function, my b term is 96. So we're going to have negative 96 over 2 times a, 2 times negative 16, right? So that'll be negative 96 over negative 32, okay? And so simplifying that, we will get a positive 3, okay? So the maximum height above the ground is going to be 3 feet. So the maximum height above the ground is 3 feet, and that's the answer to our problem. Okay, so going on to number 2. Number 2 is going to be a little different. They ask for something a little different. So a pool is treated with a chemical to reduce the amount of algae. The amount of algae in the pool t days after the treatment can be approximated by the function a of t is 30t squared minus 300t plus 400. How many days after treatment will the pool have the least amount of algae? Okay, so what they're asking for in this problem, well, first off, if we have a of t, if we have this function here to model the amount of algae, if you were to picture this and graph it, you can see that your a term is positive, right? Your a term is this 30t squared. So that's going to be positive, so that means we're going to open up, so our vertex is going to be a min. And so the next part of this is they asked us when we have the least amount of algae, and so least amount of algae, that's going to be the min value. But the tricky thing is they're asking us how many days we have the least amount of algae. So how many days after the treatment? So when does that min value occur? Okay, so they want to know, when does the min value occur? And so what they're really asking for in this problem is the x-coordinate of the vertex. So this problem actually has fewer steps than the one that we just did. Okay, so all we have to find here is the x-coordinate of the vertex. So that's going to be our formula negative b over 2a. So my b term is negative 300, so I'll have a negative 300. And then my a term is 30. So this is going to turn into a positive 300 over 60, which is going to be 5. So your answer is 5 days. Okay, so that was it. That was all we had to find, was the x-coordinate of the vertex. So they just wanted to know when the min value occurs. They didn't actually ask what the min value was, but when it occurs. Okay, and so when you have questions like that, you're just finding the x-coordinate of the vertex. So for number 3, a tour operator believes that the profit in dollars from selling X tickets is given by the function P of X is 40X minus 0.25X squared. Using this model, find the max profit that the tour operator can expect. So for this problem, we have to find the max profit, right? So this is the max value. So this is going to be the y coordinate of the vertex, right? And so to find our y-coordinate, well, the first thing we have to do is find our x-coordinate. Now, we've got this function here. If you notice, it's not in standard form, right? Your x squared term is at the end. So let's rewrite this. So I'm just going to flip the order of it. So my x squared term is first. So I'll have negative 0.25 x squared plus 40x. So then now I can go ahead and work with this to find the x-coordinate of my vertex, which is going to be negative b over 2a, so negative 40 over 2 times negative 0.25, which is going to be negative 40 over negative 0.5. And if we go ahead and simplify that, we're going to get 80. So the x-coordinate of the vertex is 80. So then to find the y-coordinate, we would have to plug that in. So we would do P of 80 is negative 0.25 times 80 squared plus 40 times 80. So this is going to turn into negative 0.25 times 6,400 plus 3,200 so we'll have negative 1,600 plus 3,200 is going to be 1,600, okay? And so we wanted to find the max profit. Well, that's the y-coordinate of our vertex, which is going to be 1,600, okay? So your max profit is $1,600, right? And that's the answer to the problem. So let's go on to number 4. So for number 4, it's a little different. A manufacturer of microwave ovens believes that the revenue in dollars that the company receives is related to the price P in dollars of an oven by the function 125p minus 0.25p squared. So what price gives the max revenue? So for this problem, what we're looking for, what price will give the max revenue. So they're actually asking for the x-coordinate of the vertex. If they were asking for just the max revenue, then that would be the y-coordinate of the vertex. But they're asking what's going to give us that max revenue, so they're just the x of the vertex. So the first thing we want to do is rewrite our quadratic function in standard form. So what I'm going to do is I'm just going to flip the order of this so my p squared term is first. So, whoops, didn't want to do that. Go back to this. Okay, so I'll rewrite this so my p squared term is first. So I'll have negative 0.25 p squared plus 125p. And then I can use this to find the x of the vertex, which remember is just going to be negative b over 2a. So that will be negative 125 over 2 times negative 0.25. So let's see, that'll be negative 0.5, and so that's going to give us a positive 250, okay? So remember they asked for what price gives the max revenue, and so a price of $250 will give the max revenue. So what that means is, in terms of the problem, if your oven costs $250, then that's the price that's gonna get you your max profit. All right. So that's it for the classwork and for these sample problems. So the key thing is understanding if they're asking you to find the x-coordinate or the y-coordinate of the vertex. And then after that, you're just working with the quadratic function like we were a few days ago. Okay, so hopefully you know enough to go ahead and try the homework on your own.